All right, here we are at these last couple of problems. Just to finish up that last problem, the last piece after 0 was positive, and so it changes directions at -12 and 0, so you would get 2 there. And then for this one, the position is given to us, so we want to find when the particle changes directions, right? This is all that same thing. We're first going to find the derivative, right, which is the velocity, because in order to change directions, it must first stop. The velocity, this one requires a product rule, so derivative of the top is 1 times the bottom minus the derivative of the bottom times the top all over the bottom squared. Do some simplification. We're going to get t squared plus 9 minus 2t squared all over t squared plus 9 squared. So our velocity function is going to be, add these guys, you're going to get negative t squared, negative 2t squared, no, negative t squared plus 9 all over t squared plus 9 squared. We want to know when does it equal 0, so we set it equal to 0. And then how you solve this equation is up to you, but something to know is that if I'm trying to make the function equal to 0, the denominator is irrelevant. The reason being is I could just multiply both sides by the denominator, right? I could multiply this side by t squared plus 9 squared and this side by t squared plus 9 squared, but the right hand side will just give me 0 and the left hand side will cancel out. So really all I need to know is when does t squared, negative t squared plus 9, the numerator, when does that equal 0? Well, you solve and you get when t squared equals 3, right? Subtract 9, divide by negative, and so when t equals plus or minus square root of 3, we can ignore the negative because up here they tell us t has to be greater than 0. So square root of 3 is where it's 0, but we still need to make sure it changes direction there, right? So I need to plug in a number left of 3. It's not square root of 3. It's, that's why I don't do these things so early in the morning. Square root of 9, which is 3, and we ignore the negative case on the 3. So we're going to plug in a number left of 3, like 2, right? So if I'm plugging in 2, like we're going over here, right? If I plug in 2 over here, 2 squared is 4. Negative 4 plus 9 is going to be positive. Recognize that the bottom will always be positive because you're squaring it. So over here is positive. If I plug in a number right of 3, which is 4, then you have 4 squared, which is 16. Negative 16, which is going to be negative. So yes, it changes directions, right? It changes directions at t equals 3. Moving over to this one, the position function is this sine function. We want to find where it changes directions. So I need to find the velocity, which will be derivative of sine is cosine. Inside stays the same. The derivative of t over 2 is 1/2. I need to figure out when the velocity equals 0. So I set it equal to 0. I can divide both sides by 1/2, and I'm left with cosine of t over 2 equals 0. And the trick to this is we need to figure out when cosine of something equals 0, right? So if you go to your unit circle, cosine is the x-coordinate. Cosine will be 0 here at pi over 2, and down here at 3 pi over 2. Now I got to keep going until I get to 4 pi, or at least I do for my t values, right? Right now I'm not finding t values, I'm finding these basically theta values, right? So if the thing on the inside of this is pi over 2 or 3 pi over 2, then I will get 0, and that's where it could possibly change directions. So I need to figure out, well, what makes the inside pi over 2, right? So the inside is not just pi over 2, it's t over 2. So I need to say, well, when does t over 2 equal pi over 2? Or when does t over 2 equal 3 pi over 2? And solve those. And so the answer is, well, when t, for this one, multiply both sides by 2 when t equals pi. And for this one, it's when t equals 3 pi. And you can see you can stop there, because if I went another revolution, I'd be at 5 pi, which is past this 4 pi, which they set a bound on 4 pi, right? So when t equals pi and 3 pi, and then I should check, right, that, you know, here's pi, here's 3 pi. If I plug in a number less than pi, say like pi over 4, right? Or let's pi over 4, what will I get? Will be positive or negative? Well, think of cosines over here are all positive. And then when I get to be between pi and pi over 3, really, or sorry, pi and 3 pi, that's really, now I'm in the second quadrant because I'm taking half of that, right? And so in the second quadrant, cosine is negative, and that also takes us to the third quadrant. And then once I get to 3 after 3 pi, that's after 3 pi over 2, then my cosines become positive again because we're in the fourth quadrant. And so yes, it does change directions at these values. We want to find for this one, we want to find the distance. So what is helpful is to know that it's a quadratic, and that in order to find distance, basically we need to find the change in position. Right? I mean, technically, change in position is the displacement. But so think about, like, if my particle is always going up, then all I need to do is find, you know, well, here, if this is time 1 and this is time 2, all I need to do is figure out, well, you know, what is this distance that they went? How far did they go? Right? The complications come if, like, it goes up and then down, because then if you just find that distance, you're not really finding the distance, but you're finding the displacement, because, you know, you go backwards some, right? It's like 2 steps forward, 1 step backwards. You know, which one's displacement, which one's distance. Fortunately for us, if you graph this, it's going up the entire time, so we don't have to worry about that. We can just simply find x of 5 and subtract x of 2, because there is no change in direction. We could show that there's no change in direction by finding the velocity, which would be what the heck? Finding the velocity, which would be 6t plus 2. And then setting that equal to 0, so the velocity would change at negative 1/3, which is not in this interval. Right? So I'm just finding x of 5 and x of 2, and seeing what the difference is. Right? X of 5 is going to be 25, 75, 85, 89. X of 2 is going to be 4, 12, plus 4, 16, 20, minus, so 89 minus 20, which will be 69. Right, so that's that.